Last week I gave a presentation to my PhD advisory committee on the progress I've made in my PhD in the last 3 years and my plan for the remaining 6 months. So I feel like now is a good time to talk about let's say, categories of fail in terms of doing an experiment. The first one is in the experimental setup. So within this, there is human error. This is obviously when you make an error while setting up the experiment. Perhaps you add 5 times more of a reagent than you expected to, or you just leave something out entirely. It might even be as stupid as just hitting a button on your calculator and screwing up the calculation. You usually know when that's happened, and so you just set up the experiment again. Next is the mystery problem. Sometimes you'll find that one of your starting materials or reagents has degraded or is just no longer working. You only know that this is a problem once the experiment has been set up and hasn't worked, and then you have to take forever to try and figure out which component you put in is the problem. Oh no. Ran out of space. This was not ideal. And then there's the random chance error where the powers of be just decide to screw with you. The things that you notice happen usually after you've set up the experiment, and they are completely out of your control. For example, a cell culture might end up getting some sort of fungal or bacterial infection. Maybe the hose connecting your reaction to the nitrogen line falls off, exposing your sensitive reaction to the atmosphere. Sometimes stuff just happens. Here's a good example right here. This is not meant to happen. Why did you do that? Experiments can go wrong while you're setting them up or while they're running, but most of the time you find out there's a problem only after you've run the experiment and you think it's worked. Well, that's weird. So even if the experimental setup goes well, there are many different ways in which the experiment itself can still end up failing. Option 1 is where nothing happens. Either your reaction doesn't proceed, or there's no difference between the control and the experiment. Basically nothing of any interest happens. If you think you've set up your experiment correctly, you then have to figure out why nothing happens. Proving that it's a genuine result involves double-checking all your reagents, repeating the experiment to get concordant results. If the result is genuine, then you don't have a result, and it's back to the drawing board to figure out another way to answer your research question. Option number 2 is obviously the experiment is successful and you get a really good result. You repeat it a couple of times, you get the same result again, and that's great. Your experiment worked, you can publish it and move on. Outcome number 3 is where your reaction kind of works but kind of doesn't. Maybe your yield isn't high enough, or your results aren't able to be repeated quite so cleanly. There are many different ways in which an experiment can kind of work but kind of not. And in these situations, you generally end up having to do what is called optimization, where you basically do the same thing but alter something slightly to see if you can get the results be a little more clear. The final possible outcome is where everything just goes horribly wrong. Perhaps you're doing a chemistry reaction and the material you put in decomposes and just degrades completely. Maybe all your cells die. Basically where the outcome of your experiment is just complete destruction of whatever you put into it. So exactly how much failure are we talking here? So let's say an experiment fails about 1 in 30 times due to human error, probably only about 1 in 100 times due to some mystery problem. Say the powers that be, random chance sort of mistakes that happen are probably about 1 in 30. Experiments that yield nothing happened results, maybe 1 in 10 times. The cases where everything collapses and goes horribly wrong is probably about 1 in 6 times. Times where it kind of worked but kind of didn't, that's maybe 1 in 2. So if you add all of these together, that's about 85% of the experiments you run won't work. Now I know what you're thinking here. You learn more from your failures than you do from your successes. I'm sure that's true. In response, let me ask you this. If you bake a cake and you accidentally use cumin instead of cinnamon, does the thought, well at least I know not to do this for next time, make you feel any better about the loss of the last 2 hours, the ingredients you wasted, the mess you now have to clean up with nothing for show for it, not to mention the disappointment of your friends when you turn up to the party with no cake that you promised? Right, now so imagine that feeling with 8 out of 10 cakes, not to mention it's a $1,000 cake and it took you 2 weeks to make it. See what I'm getting at here? So why don't I go to the trouble of telling you all this? Whenever I talk to people who have no experience with research, they seem to have a sort of glorified version of my job in their head. They have these images like the wonder of discovery and the hope of scientific advancement. And we're constantly hopeful about things that we want to achieve, make careful plans and carry out things with great thought put into it. So understandably, when it doesn't work, we get pretty bummed out. And I understand where this idea of the successful researcher comes from. I mean, as far as relating to the general public is concerned, we only ever convey our successes. We never talk about the process and the hardships used to get to that discovery. By ignoring these problems, I feel like we're making science into something mystical, which is the opposite of what it is. I want to get rid of that stereotype of the mysterious, all-knowing scientist. In reality, the average day of a scientist goes more like this. Hang on a second, that's not right. That is not meant to be that color. What did I ever do to you? Oh yeah, that's not what I meant to do.
Well, that's not right.
And looks like we'll be doing that again. Did the reaction work? Or we're going to do the same thing I did last time. And give me nothing. Come on, baby. Maybe. Ooh, that could be promising. Aha, I'm pretty sure I didn't do this last time. This is good. Onwards, to work! And there's the one where you notice that all the labels on your experiments have started to fade away because you've left them out in the presence of light. And now you don't know which is which. That's always good.